Here I go, lesson starting. Now, some of this may seem very familiar. In fact, if I go through this whole lesson, you're like, you really interrupted my work to tell me about this stuff? It's understandable, because all this stuff is just, this last lesson is like, let's just make sure all the little pieces are all tying together for you very well here. The lesson's called Powers of Rational Numbers. And I already did an example like this in another section, but I want to make sure it's clear. So powers with rational bases are calculated in the same manner as with integer bases. Now let me show you what I mean by that. 3/4 to the power of 4, what we mean is that's 3/4 times 3/4 times 3/4 times 3/4. The exact same way we did with regular exponents. It just means repeated multiplication. So if I was to write this out, then I'd multiply all the numerators. The numerator would look like 3 times 3 times 3 times 3. And the denominator would look like 4 times 4 times 4 times 4. And if your hand's getting sore writing that all out, mine too. There's a shortcut here. We want to make sure we understand the shortcut about why we can do this nice little shortcut. Look what's happened to the top. It's just repeated multiplication. 3 times 3 times 3 times 3. So that top is just 3 to the power 4. And that bottom is 4 times 4 times 4 times 4. It's just 4 to the power of 4. All right, who's ready to make a rule here? Just going to tidy that up while you got a chance to think out this rule. Who's ready to make a rule about fractions with exponents? What happens with the exponent and the numerator and the denominator? When you have 3/4 with an exponent 4 like that, which parts of the fraction get exponent 4? Does the numerator get exponent 4? Yeah. Does the denominator get exponent 4? Yeah. That's the whole rule. And like I say, if that seems familiar, it was in another lesson. So when you got a rational number, a fraction, and you got an exponent on the outside, you can just put the exponent on each piece. Then you can just go to your calculator. 3 to the power of 4 is 81. 4 to the power of 4. Maybe that one's big enough to get your attention, because that's a little bigger than people want to do in their head. So I just want to, again, bring up a calculator and show you that there's a exponent button on your calculator that will allow you to evaluate those type of things pretty easily. But you have to get to know your calculator. My particular calculator, my exponent button looks like on a little, ooh, let's find it on this calculator. Where is it? Oh, it's a little y to the x there. Can you see that there? You probably can't see in the screen. It's a y with a little x. Maybe on your calculator it's x with a little y. I've seen that on calculators before. And the one that's becoming very popular is what's called a tilde. Just looks like the little top of a house. And that's the one you'll see on computers and so on, is that little tilde thing. Yes, question?
On a supercalculator, they'll see a to the power of b.
Oh yeah? Okay, so he says that he's seen a to the power of b as well with some calculators. And if your calculator doesn't have one of these buttons, oh, it's time to upgrade. Yeah, you got 9 days now before you see me again. It's time to go out and get yourself something that's got a little bit more torque to it. Yes, and you can text me and say, what do you think of this one, Mr. Todd? Okay, but like I say, you know how much I love that Casio one. It's just so smooth once you get to know how to use it. If you've got one, I'm looking around. Let's do this right now. Let me look at the calculators you got. You're borrowing mine. This one will work fine. That's beautiful, gorgeous, wonderful. Oh yes, good. I thought that was a different one than what it was. It's good. You're borrowing mine, but that one's wonderful. So you may want to look around. This is beautiful, wonderful, wonderful. Yep, does it all, does it all, does it all. These are nice. That's about as simple as you can get and still does everything. Oh, hey, Casio, love that thing. Beautiful, beautiful, wonderful. Hey, yeah, Casio. Casio, good, beautiful, beautiful, beautiful. So we're getting in great shape now. And so on your calculator, find out how to do 4 to exponent 4. Mine's a y to the x button. Mine shows it with an exponent up there. Yours might not. It might show it slightly differently. But in the end, when you put 4 to the power 4, you should get 256. You get 256? back to here, so it's 81 over 256. So the rest of this is just me showing off how to deal with negatives. Here are the negatives out front. So the negative stays out front, the 3 gets cubed, and the 4 gets cubed. Like before with negatives, we just sort of leave that out front. If it's not in the brackets, it doesn't get repeated. That went well on the quiz. Pretty much everybody nailed that down. So if it's not in the brackets, it doesn't get repeated. So then 3 to the power 3, you go to your calculator, 27. 4 to the power 3, you get 64. This happened to a couple people on the quiz. They'd get thinking and do some great work and then not write their negative. Yeah? You got choices. Put it out front, put it in the bottom, put it in the top. This question doesn't have anything more going on, so you don't have to have it at the top. But I think it's a good habit to get into. Somebody was doing the homework and they came to me and said, hey, I like this one better. I put it in the bottom. It worked good in the bottom because there's another one in the denominator and they canceled. I'm like, great. It's not a rule that you have to put in the numerator. It's just advice. So this one, the negative is in the bracket, so it gets repeated. It's in the brackets this time, so it will get repeated. So when you do negative 3 to the power 3, you'll get a negative this time. You're like, well, that both worked out to negative. I know they were both odd powers. When it's odd powers, actually you can sort of mess up with odd powers and you still get the right answer. It always comes out to negative with odd powers. But this last one down here is the one I really want to talk about. And I don't need this one. I don't know why that's there. Because we just did that one right above there. Negative 3 to the power 4. The negative is in the bracket, so it gets repeated. Forget all this. So what happens in the top? When you do negative 3 squared and the negative's in the brackets, does it come out to positive or does it come out to negative? This should go well. Everybody got this right on the quiz. It goes back to positive, okay? Your calculator knows. If you use the brackets and put them in the right spot, your calculator knows. So if you forget from it, like, you have a brain moment on the test, like, I don't remember, is it positive or negative? Just type it right into your calculator with the brackets and everything like that. Your calculator will get it right if you type it in just right. Done? Beautiful, thank you. So proud of some people in the last section. I answered a lot of questions in the last work period. People are getting more forward with me and calling me over as soon as there's trouble, especially now. I'm just planning for grade 12 the rest of the day, so don't imagine you're interrupting me. I'll be sitting at my desk ready to go. Yeah, I'll jump right up. Me and Lilo and Stitch will come over and talk to you. Okay? That's one of 2 slides. Okay? 2 examples to finish up, and then you'll have the rest of the day to manage through that list. Any questions about this? Does it seem very familiar? You're like, okay, yeah, we sort of already talked about that, but now it's all together on one page. Last 2 examples. Okay, just to make it clear about fractions and decimals. Here's the rule the rest of the way in math classes. If a question gets asked in fractions, the teacher's expecting you to answer with fractions. If a question gets asked in decimals, then you can go ahead and use decimals. Word problems, when we get to word problems. If a question's asked in words, it should be answered in words. Okay, so those are just some guidelines about taking math classes. So here finally it's like, no, it's not fractions, it's decimals. I can totally do this whole thing in decimals. Still want to show the steps, but you can do the whole thing in decimals. So, BEDMAS is still in. So I'm going to do exponents first. Negative 6.71 cubed. Good luck. I'm not doing that in my head. So, bracket, negative 6.71, and this is where knowing where your exponent button is so important. I want to do that power of 3. It comes out to, whoa! Where'd it go? Negative 302. 3 ones, 711. Did I get all that down right? It begs the question, what do we round off to? Oh, I missed a 1. 111, 711. I think I even said that out loud and then I didn't write it down. begs the question, what do we round to? And the answer is, it depends. If this was a money question, I'd know to go to 2 decimal places. But this isn't a money question. It's not really telling me what to round to. So in this question, I'm going to carry all the decimal places, and I'll just warn you, moving forward, depending on the classes you're taking and so on, you'll know what to round to, or the teacher will tell you what to round to, okay? And this one, I'm just going to keep all the decimal places to prove I can. You say, well, it's always going to be rounding. I'm like, no, it's not always rounding. You're building some complicated device. I can bet that when they came out with the new Apple Watch this week, or one of these iPhones, they didn't round things off. It's very specific. They kept all the decimal places. They made it exact. You don't make it exact, things go wrong with these kind of devices. You're building a shed and cutting wood off. Well, yeah, you can round as long as it's close. It'll be all right. Building iPhones, no, we're going to need all the decimal places. I'm not getting carried away on that in this chapter. I just want to introduce that idea that decimal places we might need more or less. And then 2.3 squared. I've got a squared button on my calculator, so that's a little handy too if you don't want to use your exponent button. Oh, look what my calculator did. It went, do you want fractions? I'll do fractions. Like, no, I'm doing decimals here. So on your calculator, you'll have to, if your calculator does stuff like this, you have to know where the change button is. Some of you have an SD button or an FD button, and that'll change you from fractions to decimals when it does that on you. Because I wanted 5.29 here. This question was asked in decimals, so I'm going to answer in decimals. The screen setup's frustrating me a little bit, so I'm just going to move things around a little bit and hopefully be able to do both of these at the same time. Oh yes, that works good. I did the exponents. What's next? After exponents. Multiplication, I got to multiply these two things together. I got to keep my writing small. I hope it's not too small for you to see because it's really, really long here. So I got to take that -2 and multiply it by the, negative 302.111711. 1117. Too many ones there. Whoa, what am I? Whoa! Plus. Okay, now I'm going to write this down like this because I want to address this negative situation. 422 plus the 5.29 over there. Now, this came up yesterday for a bunch of people. They said, is this negative 2 times negative 302, or is it subtract 2 times negative 302? And I definitely frustrated one person because they asked that question. I said, yes. What they're really asking is this thing here, right there, that sign right there, ooh, blue. Oh, that was from earlier, right? I put it in blue. We don't want blue. I want some green. Is that symbol right there, is it a negative or is it subtract? And the answer is, yeah, it's negative or subtract. You might think I'm playing games. You think, oh, Mr. Todd's just messing around. No, it's true. You can think of this as negative or subtract. If you think of it as negative, you are -2 times negative 302, so you're adding, because negative times negative is positive. If you think of it as subtracting, then you'll be subtracting a negative, which you'll be adding, and it comes out okay. So whichever way around you want to think about it, it totally works. It better. Math has got to work, right? We need it to be right, so it totally works out. And then I told you when you get down to adding and subtracting, you don't have to show me an extra step. You can just add this right across. Maybe take a shot at punching in your calculator as well to make sure I get the right thing here. Negative 6.02 plus that crazy 604.223.422. 223.422. And then a 529 to add on the end there. I get 603. Back to my pen. 603.493422. If you're freaking out about the decimal places, you're totally right. Most questions will say round to 2 decimal places or something like that. I was just going through it once so you could see what it was like with all the decimal places there. Did anyone else type this in? Did I type it in right? Did you get the same thing as me? Yeah, I'm getting some thumbs up. Good. Okay, one last fraction question. This could have been in the last section. It's just one last practice one to make sure we got this all down pat. This one just happens to have an exponent in it, that's all. One more time. Tell me about the bracket thing. What is it about the brackets in BESMAS? What are we really trying to accomplish in that bracket stage? Yeah, stuff that's in the brackets that we're going to work with. And I do have stuff in the brackets here. Now, this is where all the weapons now. You're going to feel like a juggler now with all these math rules I put in there. Where you're like, okay, I got BEDMAS, I got that going on, and now I've got to have that, how do I deal with negative fractions, so on, from the last lesson. Got two negative type fractions in the brackets here. What two things would you like to do to this thing to make it as easy as possible? They're not rules. This guidelines that I gave you in the last lesson to be able to handle nasty negative fractions like this. Let's go improper, yes? I'll get to the other rule in a second. All right, I'll come right back to you and ask for the other rule. So I'm going to go to improper. Ignore the negative for a second while you think it through. 1 3/4 is 7/4. And now come back to the other rule. Ooh, I got a negative to put on it. The second rule was, where should I put the negative? Where is it going to be easiest to put this thing? In the numerator, yeah? Okay, so that was the second of the two rules. And more repetition here. What do you absolutely have to have if you want to add or subtract fractions? Common denominator. It was very good on the quiz here. I only saw like 1 or 2 people who got a common denominator for multiplying and dividing. So for multiplying and dividing, you don't need a common denominator. Things just get out of hand when you do that. For adding and subtracting, you do need that common denominator. So, common denominator. Common denominator of, well, you could use 24, but it's worth a little investment in time to go, is there something smaller that would be nice here? 12 works here. But again, if you're just multiplying these two things to get your common denominator, it works. You just got to do a little reducing later, that's all. I'm going to go to 12s here. Negative 21 over 12. And this is 10 over 12. So, negative 2 2/3. Negative 21, subtract 10, I get negative 31 over 12. Now, today's lesson, this lesson that I'm teaching right now, what do we find out about squared? Does the numerator get squared? Does the denominator get squared? Do they both get squared? Does nobody get squared? Who gets squared in all this? Both get squared. And I like the extra step here. I go, okay, negative 31 gets squared and 12 gets squared. 31 squared. 31 squared. 930 and 30 and 1, 961. Do you trust me? Well, you shouldn't. I don't even trust me. Well, I do, but it's important to check these things. 31 squared, 961. Okay? What a mess. My, what a mess. What a giant denominator. I'm just tiptoeing up on giant denominators here. You know, on the quiz there was one that got a little big there, and the homework's got a couple that are a little big. Try not to get out of hand on the test, but I do want you to practice with some big denominators. Okay, now this is just adding. What would you like to do with this mess here, this negative 2 2/3? Two things we'd like to do. Go to improper. Ignore the negative for a second. 8/3. And one more thing. I got a negative. Where would you like to put it? Best place for it is up top. It's not a rule. It's handy. 3 and 144. Oh my goodness. Common denominator. How would you handle this? What would you find it? Would you go right? Would you multiply 3 and 144 here? Would you just go, I give up. I'm going right to 532. You can. It totally works. But just to check, maybe. The only other possibility is that 144 might work. So we check. We go, okay, let's just check. 144 divided by 3. Ooh, it does. It works. Okay, so if you do notice things like that, you can keep your numbers smaller. So I got to multiply top and bottom by 48. That'll give me 144. And I got to multiply that top by, what did I say, 48. 8 times 48. 8, hey, I love how that sounds. 8 times 48. 8 times 48. 320 plus 64, 384. I'm making a mistake on purpose here because I saw a couple of people make this exact mistake on the quiz, so give you a chance to think about it while I go back and double check my mental math to find out if Mr. Todd's getting old yet. 48 times 8. Still got it. I can stay one more year. What did I miss? I got distracted. Yeah, it can happen. You get distracted, you're doing some mental math, you're playing around, you go, oh, I'm so good at this, it's going so well, I remember all the steps, I'm so smart, and then it's easy to forget a little negative in there, right? That's why at the end of these questions, typing the whole thing in from the start in your calculator and checking your final answer is such a good move because it catches those little mistakes. Negative 384 plus 961. Can I do it in my head? 577. I don't even know if it's right. I'm going to look again. 577, 8, 950. Oh, it is. I think it is right. 577. And then reduce this thing. Oh, my God. Oh, listen, if they're that big, I don't know what. I got to tell you, we don't get wound up about reducing all that much and checking your steps and going, oh, you didn't show that exact reductions there. On your quiz, I didn't get too crazy about it. They get this big. Let's lean on the calculator a little bit. If you go 577 over 144 and press equals, it tells you. Yeah, it gets it down for you. So if the numbers are reasonable, I really want to see the work. You know, we're talking about 12s and 14s and 18s. Come on, show me the work. When they get out of hand like this, hey, well, let's not get crazy here. Let's use the technology we have available to us. 192 and a third. Was I right? Is all of that sort of familiar? It's really just tying everything together we saw? Yeah, okay. I'm not saying that you don't need that lesson. There are some difficult parts to it, but I just wanted to tie that whole chapter together for you. So I knocked it to 2 slides, and take a look. That homework only has 2 to 7. You're like, oh, only 2 to 7. Thanks a lot. Look at this whole page of homework you're giving us. Yeah, I get that. I totally get that. But I did modify things down a little bit. Any questions about this example before I stop the video? Don't forget, those videos are going to be there. If you're doing your homework and you're like, oh, I forget how he did that. Well, what was the approach there? What did he say about that? You can go back and watch the part of the video you need to.